Okay, good evening everybody. Thank you for coming in from the sunshine this evening for the presentation on Bergen Light Rail. My colleagues here, Jim Sherry and John McInerney, will be presenting for you. I'd like to welcome you on behalf of the Railway Group. I'd like to take this opportunity to introduce you to the new Mott branding and logo, which Motts are rolling out this year. Some safety information: there's an exit here and an exit up here in case it's needed, and there'll be some questions afterwards. And with that, I'll pass you over to Jim Sherry.
Thank you, Bruna. Good evening, ladies and gentlemen, and welcome. I'm Jim Sherry. I'll give you an overview of the overall light rail project in Bergen. I'll talk through some of the project logistics, and I'll just touch on some design features of interest. And after that, John McInerney will take you into more detail on some of the design features of interest. We'll go into the systems engineering of the project, and most importantly, we'll go through the BIM aspects of the project. Bergen. It's the second biggest city in Norway, population a bit under 300,000, but that's Bergen city. The bigger Hordaland county, or the greater Bergen area, is about 500,000. It's a beautiful city. It's the wettest in Europe, we're told, 3 times the rainfall of Dublin. And interestingly, the light rail system is funded by local and national governments, but substantially by local road tolls. And some of the road users are not very impressed with this, especially some of the taxi drivers. As you can see from this photograph, it's a beautiful city, but it is built on mountains and hills, therefore the development is linear, and you will see how that's important when we look in more detail at the overall light rail. A very high-level overview. Our client for this project was Bibanen Utbygging, and that is Norwegian for light rail development. Bibanen being Norwegian for light rail. And interestingly, this is not the first light rail system in Bergen. They did the tram system in the 50s and actually dumped some of the trams at sea. This is at the same time as Todd Andrews was closing down some of the rail lines in Ireland, including the line that was eventually used for the Green Line Lewis. So, full circle, we're beginning to learn. If I look at the overall light rail rollout in Bergen, it's 5 stages. The first stage starts in the centre of the city, Centrum, and runs out with the second stage to Lagunen there. They're currently operational. And the third stage is from Lagunen to the airport, about 8 kilometres, but a lot of engineering, and there's a large workshop and depot for the overall system there. In the future, they have stages 4 and 5, and they will start to the west and move through the city centre again to the north. And the workshop and depot is designed to allow for this future development and development beyond that. Because of the mountainous terrain around Bergen, it means linear urban development, and that enables them to have a vision that for the whole population, the 500 million, 80% of workplaces and 50% of homes will be within meters of a tram stop eventually. Our element of it, as we said, runs from Lagunen to the airport. We start off here, as you can see, the green are the tunnels, so there's 1, 2, 3, 4, 5, 6. The last tunnel bringing us in under the new terminal at Flesland Airport, and the workshop and depot is just in that area. 6 tunnels, 4 bridges, workshop and depot, over 8 kilometres. At the beginning of the overall rollout, the programme was stage 1 would be operational by 2010, which it was. Stage 2 would be operational by 2013, which it was. It was under construction while we were designing. And stage 3, which is our element, will be operational by 2016. And it's on programme. It's due for commercial operations to commence in August after the Norwegian summer holiday. They go for holidays for 5 weeks in July. And the connection into the airport will be operational in 2017 when the terminal itself is complete and opened. The scope. Stage 3 was order of magnitude 450 million euro. And what do you get for that? You get 8 kilometres of double track, another 8 kilometres in the depot. You get 6 tunnels, you get 4 bridges, you get 3 pedestrian bridges, you get a couple of culverts, you get portals for the tunnels, you get 7 tram stops. You get a large workshop and maintenance building for the overall fleet, and you get a parking hall because of the climate in Bergen for 40 trams. As well as that, you get an administration building and an OCC, or operational control centre. The building will service the drivers, the maintenance staff and the overall administration. And you get a 2-storey park and ride with the bus stop and tram line on the roof of the park and ride. Okay, we won the project. Now what? MacDonald had no initial presence in Bergen. We had an oil and gas presence in Stavanger, but that was of no use to this project for us. So we had to set up a local company, Mott MacDonald Ireland, Norway Limited. We also had to set up a local office with staff, but with suitable IT infrastructure for the Mott MacDonald systems. And that's not straightforward. That's a piece of work in itself. We had to get the staff. All of this at the same time as we were doing the optimisation stage with the client. And in addition, we had to register and demonstrate compliance with the Directorate for Building Quality before we could make any planning submission applications. A complex project like this across a whole range of disciplines within a company like Mott MacDonald needs to be done with a multi-office approach. This one, we used 10 significant Mott MacDonald offices across 6 different countries, and we had Pascal and Watson in Dublin and Limerick for architecture. We had the RPA in Ireland for specialist support. We had Ramboll in Norway to help us with GPROG. I'll talk a bit about that in a while. And we had ACK Architecture, who fulfilled Ansvarlig Søker, or responsible applicant role. This is very important from the planning, because their requirement in Norway is that there is a single focal point for all planning applications, submissions, documentation and the like. And this person is administrative but has to understand the project and have a very good relationship with their counterpart on the other side in the commune. For this, Mott MacDonald, the reason we were able to make it work was because of our collaborative working processes, BIM, as John will go through, our common data environment, a very good extensive use of Link, our internal PIM system, and our internal project-wise system internal to us and used by others. So, what does a project like this mean in pure engineering terms for the design engineer? 354,000 man hours. 2/3 of that was Ireland based, and that's the equivalent of about 34 full-time engineers for a 4-year period, which in 2012, when you consider the state our consulting industry was in, was quite important. For Bergen, we made an early strategic decision not to have an awful lot of people with a full-time presence there. The reason for that was that the client interface days were Tuesday, Wednesday and Thursday, and as well as that, Bergen is a very expensive city to live in. So that meant we had probably 8 or 10 technical staff maximum based in Norway with Norway contracts, but it did mean we had an awful lot of travel over and back to Bergen. We had over 1,200 hotel nights, we had over 1,200 flights, and bear in mind that to get to Bergen there's no direct flights, so the round trip is 4 separate flights. We got used to working on the run. This is our design team in Bergen on a Thursday evening waiting for the flight home. I hope they were working, maybe they were just surfing the net. Just touch on some commercial aspects of managing a project like this. When we tendered a fixed price in Norwegian kroner for a large design project. We tendered time charge rates in Norwegian kroner for changes for construction support. And these were blended rates necessarily, because I have one rate for a senior engineer, whether he's sitting in Dublin, whether he's sitting in Norway, whether he's a Norwegian engineer, whether he comes from Prague or even South Africa. Travel is all included. And we blended across the different costs. During the project, my costs were euro, sterling, NOK, rand, koruna, forint, and a couple of others. And I'm getting paid in kroner. And we started off, we tendered at about 7.6 to 1. And unfortunately, the downturn in the oil industry came along, and the worst case was 9.6 to 1. And that meant that I was getting 25% less euro for the kroner the client was giving me. Now, the fact that I'm standing here, I suppose, says, yeah, we managed our way through it. It was part of our scope to go through all the permitting and permissions for the project. It was a challenge for us because we're in a new country trying to learn all these, but we got to grasp with it quickly. It is complex, but it is similar to the setup in Ireland with Bergen Commune, the equivalent of, say, Dublin City Council. There is the project zoning, there's the planning permission stage, there's the permission to build and the workshop stage. The planning permission stage, incidentally, requires that you get a letter of no objection from each of your neighbours. That would be an interesting approach in Ireland. And the commune won't let you go ahead unless you have demonstrated you've made significant efforts to get this. The architects had to present the Depo Design to the Cultural Committee before we could go forward for planning. We had a railway safety case with the Norwegian Railway Authority. Our roads and bridges, and there were a good few of those, had to get approval from Staten-Vestvegen, the equivalent of our NRA or now TII. And our traction power system had to be gone through and approved by BKK, who would probably be the equivalent of the old ESB that we had in this country. Stakeholders for the project, Biban IS, they own and operate the train system within the overall county. Stadler have a significant tram supply and maintenance contract, and in parallel to this stage 3 rollout, they're providing up to 28 new 42-metre trams. As well as that, they will be extending in the new workshop the existing 32-metre trams to 42-metre trams. Keolis have a tram operating contract, and all of this interfaced with our design so there were stakeholders for us. The county operates the workshop and owns and operates the park and ride. Avanor, the airport authority, are a very significant interface or shareholder for us because they're developing the terminal at the airport and we're putting a tram stop in at the bottom. They're also a neighbour to the depot. They have a new runway, a proposed new runway 180 metres away from our fence. So we had to work very carefully and closely with them to make sure they were happy with what we were doing before we could put our planning application in. And the military owned the land north of our depot site, so we had to talk very carefully with them and make sure that they were on board. Going to a country like Norway or any other country, you need to understand what I would call the construction environment. I don't mean the weather or anything like that. Now, we had to understand the weather as well. It was different from here. But how they do things. There's no point in us coming in and doing design our way and running things our way because it'll cost the client. The contractors won't be used to it. The first thing to probably touch on is a thing called GPROG. It's a bespoke piece of software used in Norway on all government projects. It's effectively a combination of a specification and a pricing document. Different from the way we do it here. We used Ramboll to do this because it's all in Norwegian, but a critical point about this was that all our designers had to understand what was being done within GPROG, had to buy into it, because their design is their model, their drawings, and the GPROG. That's what the spec is. They need to understand that it works, that it's their design. We use Norwegian contracts. We had about 15 different construction contracts. Now, interestingly, in Norway, the client administers the contract and the consultant is the other side, contractor, client, consultant. A bit different from here. Our reason for using the different contracts rather than a single contractor was twofold. In a very busy industry at the time, there was a perception that a small number of large main contractors wouldn't be cost competitive. In addition, there's a lot of specialist work here that you wouldn't get a benefit from a large contractor, or at least that was the argument or the perception. Track, OCS, equipment supply. They have different construction projects there. They use a thing they call O drawings, which is a bird's eye view of the finished product to scale, showing exactly what's there. Our BIM approach and 3D model was perfect for that. Language was a big issue for us. Norwegian was the contract language. Emails in both languages. They emailed Norwegian, we did it in English. Our deliverables, both Norwegian and English. So translation was a key aspect of the job. We started off with an optimization stage. Now, to me, this is quite interesting because we had a contractual requirement with the client to develop a stated number of optimization points for each of the designs before we went into detailed design. And we had to, for each point, go through, analyse and assess the functionality, demonstrate the strategy for implementation, look at risk factors, look at cost and programme impacts, showed the client it was value for money. We used a decision paper process for this. Again, this is something a little bit new to me, but I will bring it forward in other projects. We used it during optimization and in the later detail design stage. Decision paper, you identify the issue that needs the decision. You determine what options there are, costs, the program associated with them, the functionality, pros and cons. That functionality can be across a whole range of disciplines. You make a recommendation to the client, you say, this is the issue, those are the aspects, I recommend this. He either says, yeah, I buy into it, or no, I want this. Or he goes back to you and says, no, I need more information, I don't have enough information to make my decision. But it's a great way of working because he's clear on what information he has to give you, decisions he has to give you, and you have clarity on the decisions that are made, and there is traceability, both for you and for him within his organisation. John will give you a good example on Rastolan when he comes to it. Okay, design features of interest. On a rail line like this, 8 kilometres with such terrain, there's all sorts of features of interest. I'll try and touch on a few in the next few minutes. If I take a look, for the depot itself, we went to significant extents during our optimization phase to look at the various options. We had a constrained site, but there were still different ways you could develop. The whole team came together, assessed, who developed parameters, weighted the parameters, all of that. We chose option 1, brought it to the client. The client said, yes, I go with option 1, makes sense. And I know I'm turning it through 90 degrees, but while this is based on option 1, this is the final layout, it is not the same. We've ended up covering the points because of weather. We ended up because of positivity, but allowing for future expansion. We didn't excavate that area, 30 metres of rock, too expensive. We moved administration building. The point about this is, even though we've agreed with the client what the design is, design will develop. He had to make changes, but there were reasons for these. All big projects like this are live, and you need to be able to run and move with these designs. BIM helps. On a much smaller scale, how we helped work with the contractors. This is an example. They weren't very used to slip-forming curbs. We introduced them to the concept of slip-forming curbs, worked well with the contractor on it, and what this meant was that in this area here, between the two curbs, once the curbs were done, we were able to finish out that area and allow the track laying contractor in. He was able to get into that area. It was a separate contractor, could get into that area a couple of months before he had expected, and this helped program issues. Yes, Bergen shift. It's a bus terminal and a light rail interface. It's quite a complex piece of engineering. I'm starting off here with the existing road to the airport. I'm bringing my light rail system over on a new feature bridge we designed into the stop, and again on out to the airport, back into a tunnel there. I have a 2-storey half underground car park there. I have a reconfigured and dualized road there for the buses to bring them in and up for the bus terminal there beside the line. So we had to re-engineer all of this in a very tight space, and just the type of thing you have to deal with. The cycle path comes along there, we ramp it up over a new pedestrian bridge, link it in because we bring the cycle and pedestrian facilities across the new feature bridge. But if you want to go to the airport on your bike, you dip down again under the bridge. Complex piece of engineering, but this is just one small piece of the overall project. For the depot, we worked very closely with Stadler, with some support from the RPA, in terms of understanding their maintenance requirements, developing whether it was light or heavy, outsourcing, not outsourcing. We looked at preventive, corrective maintenance. We worked through balanced exams with them, and we ended up with what we believe is a good layout for the depot. At the bottom, we have 3 through lines, or rather 2 through lines for light maintenance. Further down from that, there is facility to expand. I noted that earlier on. The heavier maintenance is at the top with the bogie workshop, and we provided a complete painting, enclosed, ventilated painting and bonding facility, which they required. These are some sections through, again, the approach to pits, with the pits versus swimming pool, was all developed carefully with the maintainer to understand his work processes, material flows, and the like. And again, a complex piece of engineering once you start to look into it in detail. Separately from that, we provided a significant amount of equipment advice. We were able to do this because we have a significant rail resource in our Altrincham office, and we got some support again from the RPA. We developed contract C35 for the tram wash system, C36 for the tram sanding systems. Now, these obviously had to be linked to the overall operations because you need to understand the throughput rates required. Tram lifting, within the depot there's a fixed tram lift in one lane, we have mobile jacks in another lane. We put together an overall maintenance equipment purchasing contract, C38, wheel lathe, various stuff, underfloor washing, a rail drop for the bogie shimming. We even got a new rail shunter. That's some of the engineering aspects of the job. If I take a look at these two photographs, collaboration and getting our design working together was a key for this project. And while these photographs look nice, they look very straightforward. If you look at the one on the right, I'm starting with a tunnel, I have a bridge, I have track over the bridge, I have OCS, I have ducting, I go into another tunnel, I have a tunnel portal, I have a road leading up to it. This is an emergency access to the two tunnels. Photograph on the left, I'm adding in retaining walls, I'm constructing beside other constructions that are happening. I have a cycle lane going by, I have landscaping. All along the line, all different. So a complex piece of collaboration. Again, the bin helps enormously with this, taking it through to construction. That's engineering. Just a few words about architecture. As I said about the depot, because the depot is close to the airport, it's the first thing you see on the road as you're coming out from the airport. It was within the zoning, there was a requirement that we make a statement with this. And I remember sitting in early presentations from the architect. The architect was talking about different ways of approaching it. He had a concept of reflecting Bergen with steep pitched roofs to reflect the old UNESCO site, reflecting the landscape in the area with not quite steep pitched roofs but different flowing shapes. Or you could go back to what we call the IKEA solution, a rectangular box. The client bought into, and the cultural committee I mentioned bought into, the landscape version. And I'm, as an engineer, a project manager, looking at this, scratching my head, but if they like it, they like it. This develops to a more textured and coloured. This develops to a presentation model, and this develops to the finished product, which at the end of the day, when I consider the colours and the sharpness and the forms that are presented, is a fine piece of architecture, and the client and Bergen commune are quite happy with it. So as well as us engineering, there's a considerable architectural element, and I need to give Pascal and Watson credit for that. I think that's as far as I can take you. I'll hand you over to John McInerney and he'll go into much more detail on some things. Thanks.
Thanks, Jim. I'm John McInerney. I'm going to continue discussing some design features of interest, show you how we did some of the railway systems engineering on the project, and then describe the development of the building information modelling and CAD management on the project. Yep. Okay, the first feature I've just selected. This is a Deerhoff tunnel. It's a rail tunnel, which meant from the normal rail tunnel design in Norway had the tunnels dark. However, because there was an additional request to put a pedestrian and cycle path in, that required a section on the right to be well lit. So it's a wider tunnel than usual as well. It's a 19-metre width with a skew span portal, and I think you can see that we have achieved slightly the light and dark quite well. Another design feature I picked to show you is the design optimization point, which was the selection of the first turnback on the extension phase. So the original phase is about 12 kilometres, and we added 7 kilometres, and the question was where to put the turnback coming out of town. And the original design was to put it at the end of the second phase. But we expanded the range of options and taking a look at taking it one stop further into the first stop on our extension project, we included that as an option. And although it ended up being a more complex stop, and a slightly longer journey time to that point, there was big advantages in because it was quite a good passenger collection point as well. So taking it all together, this is an example of the options compared across the different dimensions that they selected. And that's the solution which we preferred, which is it's called Rastolen Stop, and it includes a pedestrian underpass, and there's a school here, so it should be quite a busy stop. And that was the engineering model, which was developed in CAD and constructed from. And that's the visualization model, which was developed from an early phase of the design of that tram stop. So just another selection point is the terminal of the new extension is at the airport. And we come in underground through a tunnel, and we come in at basement level, and we have the escalators and elevators here. So as part of the design process, we had to include the alignment, fire, smoke, passenger movement, signaling, and operations and timings. These were all considered as part of the design process to come up with a suitable layout and alignment. And obviously interface with the airport operator as well was included. This is just an early visualization of the platform level, particularly the lighting was used there. And this is the construction a few months ago. This is the airport tram stop as well. So on a project of scale, we adopted a system engineering approach to our design. And we had overall responsibility for all the civil design, for the substantial parts of the electrical design, and interface with the two turnkey contractors for telecoms and railway signaling. So we were responsible for delivering the reliability, availability, and maintainability studies, and the safety management studies as well. We delivered the safety management, including hazard operations studies right at the start of the project, and then several years later the hazard ops were closed out by reporting on how all the various hazards were tracked and closed out. The system engineering approach breaks the project down into parts and goes through it very systematically. And I'll show you that here. We basically take a look at it from three dimensions. We look at the system's requirements themselves. We look at the various number of contracts that the client has chosen to break the job into. And then we look at the organizational requirements from operator. Jim listed the organizational requirements. So we have to analyze all three, and then we did a breakdown at the start of the job. So initially you have all the input requirements from the previous phase. You have the sort of organizational requirements, and these are the contracts, and that you end up with your design output on the right hand side. So this is a systematic approach to your design, and it allows you to manage, coordinate, identify your interfaces, and control your packaging. Having done a system engineering approach, a lot of our design was able to be developed completely line-wide. For example, we did a full line-wide 3D ducting design, taking account of all the requirements of the engineering, all the electrical engineering packages, the turnkey packages, fully developed in 3D and constructed from the model. 56 kilometers in total of ducting. We're having developed the model, we were also able to, without very much additional work, generate a cable management and duct management system, which is an example here on the right hand side. And this was useful during the construction phase. The turnkey contractors were able to use the same management system themselves, and after the project we hand over, during the project in fact, and afterwards it was handed over to the client, who's the local council, so they can use this system for their future use of the cable management system within the line and the depot. It's a live system. We also took a system engineering approach to the speed profile design. It's quite an iterative process between the railway alignment, the rail signalling, the overhead conductor system, taking account of journey time, driver approach to speed limits, and passenger comfort and safety. So you have to take all these parameters into account, and you have to iterate several times. But having overall control of the process allowed us to reduce and eliminate all non-compliances. Our traction power design for the project, we had to, we went back and looked at the full line all the way from the city centre all the way out to the airport, and we modelled the full line to get a complete journey time analysis. On the extension, 7 kilometres, we used our train traction power simulation model. This is the loads in each individual substation, and this is the voltage profile on the overhead conductor wire. We optimized the design to have three new substations plus one in the depot. So now I'm going to just explain a little bit about how we managed our building information modeling process. In 2011, when we were invited to tender for the project, the Norwegian client was very interested in BIM. Norway is one of the leading countries in BIM, particularly in building side of new design processes, three-dimensional designs, and they've developed a lot of new standards and requirements. So we took it on board as part of the tender process, and we took it on board, and the requirement was to generate our design using a three-dimensional model and deliver it throughout the project, use it for coordination, and use it as a basis of design and a basis for construction. During the project, we had 337 separate three-dimensional models and about 2,000 releases of those models at stage points. Eventually, the project was very successful, and we have won a couple of awards for that. So I'll just show a little bit more about the modeling. Firstly, one important point is that our design teams were distributed. I hope maybe you're watching this from abroad, but we have Dublin, Cork, London, Budapest, Bristol, Prague, Brno, Bergen, and further afield. And using network technology and appropriate software, the design teams were able to view each other's models and work live on their own model, whilst having visibility of the other design teams. We use ProjectWise, which is a Bentley product, and this allows controlled management of software. And this is the flow of number of licensed users on the software. And you can see that, like, within 1 quarter, which is 3 months, we had about 100 users just brought on just from the initial startup on the project. So it's a very efficient way of getting teams working together from wherever they're based. Of course, with a large number of models, it's important to manage it. So the BS 1192 is a standard for information management. It's becoming much more popular. It's mandated in the UK actually from April this year. And the main point about it is that it defines the models that have to go through a control phase of the state from work in progress to shared, and that has to be shared with the full design team, the actual live model. And then it goes through published and issued, and then it goes back again. So that's how a single model has to be managed and tracked. Obviously, when you have a lot of models, the challenge is how to organize your activities. So this was our information architecture for the project. So we're just sharing it here, and this is the commercial management, and this is the design management, and it's very traditional. There's the actual design activities and construction, but just for interest really is there's a sort of third role when you have building information modeling of an information manager, and it's hard to explain, but it's not the exact engineering manager, and it's not the pure CAD manager either, and it's the management of the information process itself, the integrity of the information, where exactly it is, who has the information, is it being released. So it's an interesting part of the design process. And we also implemented controls. Having 2D information and 3D information available at the same time means you have to understand where you are with what information you've released to people. So we found it useful to track with databases between our 2-dimensional and 3-dimensional states of our information. And now I'm going to show you a short video of the 3-dimensional model. So we start at the car park, which Jim mentioned already. This is an underview as well of the ducting and drainage. So this is an overview, some selections of different models. It's just statistics from the main line. We're going to zoom out here and zoom in again on the depot. So the depot design was, the buildings parts were done in a set of Revit models, different ones for architecture, mechanical, electrical, and structural, and equipment specialist models as well. The site itself was modelled in AutoCAD and MicroStation. Different components, different designers were using their own software. But by being able to coordinate and see each other's models, we were able to coordinate the design. Extracting the information was available, and some of the fabrication steelwork companies used the 3D models as part of their fabrication process. From the Tekla model directly into their fabrication. And that's the site construction. Then with the drones and the scanning now, and we were able to combine the scanning results with the 3D model, design model, so it's a good way of checking progress. This is a visualization inside. These are some early designs of the depot. And this is a line-wide run-through of our engineering model. And the main point here is that the model here has been built up from the 3D design, and the only representation that's been added is the textures on the finishes, surfaces, and some trees and things. But all the hard infrastructure and buildings, equipment, it's all the engineering models, fences, poles. The ballast is a texture as well. That's okay. That's the end of the model. So I'll just continue with some of the details on the how we delivered BIM. So at the start, a key thing was the selection of the correct software or most suitable software. We looked at MicroStation, AutoCAD, Revit, Civil 3D, and we ended up using a combination of these packages. One of the key points was on interoperability between models and versions of software, and we found MicroStation actually very useful for this. Although other packages, it's able to work with other packages as well. We obviously invested, Jim mentioned, we invested in some upgrades of our hardware and networks. We built a new office in Bergen, and the software environment we selected was suitable that we could share information with the clients and the contractors as well. This is the sort of software architecture, and the engineering packages and engineering design teams would work on these packages here. And although they're working in these packages, the files they'll save will generally be a DGN or DWG, AutoCAD or MicroStation files. And by saving in these environments, the teams can see each other's designs on a live manner. They can be coordinated to Navisworks and exported and shared by a Navisworks Freedom, which is a free viewer. So that was exported weekly to the clients and contractors as project progressed. And you could see individual disciplines and individual contract sections and so on. It's very useful for class checking and tracking progress. So a key design decision that we had to select and we worked on at the start of the project was what level of detail to pick as part of our design planning. We didn't want to do too much, but we needed to do enough to pick a level that was suitable, enough detail for coordination, so that each discipline would just generate as much detail that was useful for them and as much detail as would be helpful for coordination with other disciplines. as a principle. So we picked, for example, with OCS, overhead conductor systems, we modeled the poles themselves in full detail, but we didn't model the equipment on the poles. There was no need for that. And we modeled, for example, electrical cabinets, actually the correct dimensions of the cabinets. We modeled the bases they were sitting on, but and actually the duct pipes, but we didn't model anything inside the cabinet. So that just gave us pretty much what we felt was the right amount of information to model in because we were doing it in 3D. And that worked quite well, and it was kind of consistent throughout the project. It was an early decision, but it paid off later on. So this is, having done the three-dimensional design, in fact, on site then, the contractors, we noticed a couple of things. It was quite successful in that between the design phase and the construction phase, there wasn't this huge gap, which is like the takeover between when the contractor has to study an awful lot of drawings and there's maybe an awful lot of questions which can take time. The three-dimensional models sped up that process, and the contractor were with the model. And if you look at this, I think there was 75 kilometers of underground drainage, but this is just one section, and here the contractor then asked for that to be simplified for his actual construction purposes. So that's just a string, AutoCAD string files, and he was setting out directly from the string files. Here's another section, which is Sandsley Tunnel Portal down here. And you can see the individual designs here. This is ducting, this is the road and bridge and so on. But then underneath this, there's the earthworks model. And by delivering this earthworks model to the civil contractor, he was able to feed this one straight into, this is the control cabin of his digger, and this is the sort of surface of that earthworks model. And this is, this is a digger. And if we look at, this is the bucket, this is the cabin of a digger, and this is the bucket. So we're not saying this digger is at this position, but this was possible, and the contractors did actually achieve this in certain locations, and they were quite interested to do this as well. I mean, this technology, it was new for this sort of civil roads construction and rail construction, but it's been used on mining projects for a long time. I think they've found that out for me. So just to summarize on the building information modeling end of things, we found that by working on the models, it allowed individual designers to have a shared understanding of what was happening. The contractor, the clients, the stakeholders, and so on were also able to see what was going on. The visualization models were developed rapidly from the engineering models by just adding some textures, lighting, finishing, very little additional work. And these were great for the public. Sort of about halfway through the design phase, this enabled public interface very good. The models were also useful during the construction phase, on the one hand to check construction progress, but also they were actually used by the contractor for construction, setting out directly from the model, as opposed to usually maybe schedules of coordinate points and so on are given. It's a very onerous task normally. So we found the model went very well, and the client's survey manager, who was also in charge of his CAD process, he also felt, and he stated it was possibly the best model he'd seen on a work of this sort so far in his experience. So that's our presentation on the modeling, and ready for some questions if there are any now. Thank you.
That's great. Thank you very much, John and Jim, for a very interesting project presentation. I think a lot of us are familiar with this, but it's great to see a presentation of this sort and to be acknowledged by the ACI for Design Overseas Award and the FETAC Award that we also won last year. To open up the floor now to any questions that you might have. John and Jim, if you'd like to join me up here for the microphone so as the webcaster audience can hear. I'll just take the microphone so as they can hear also. So, any questions?
Jim,
Seamus.
you what was added when you started, would you?
Without question. I'm looking forward to the next one.
Could you maybe, Jim, develop, you were starting off, this was our first major grim project, like the learning curves were quite steep in places, and also the Norwegian environment of that. Could you expand on what some of the challenges were there? I think Jim maybe mentioned the Norwegian environment, but taking on such a big project. Yeah, well, we had experience in London office, had done a big job, a rail job, Victoria Station Underground, and there was we got a good technology transfer there. There was the basis of the software selection was chosen using systems that had already been proven on previous jobs. That's important to note. It wasn't a complete leap. A lot of the design team as well had done previous work in 2D and in 3D, although not in complete 3D and not in the same level of coordination. There was a learning curve on the 3D with the 3D designers. A lot of the learning, a lot of the people actually got into it, and it was quite interesting. People can see it's a way of the future for some design. So some of the training wasn't necessarily onerous. People were quite enthusiastic about it. Certainly management of the information flow and the information process, those earlier slides which I showed, and maybe they look maybe very boring, but to think of that through, and planning and the scheduling of that, it would have been hard if we were doing it from scratch, but we had quite good, we used ProjectWise to manage the filing systems, and that worked across offices. We had quite good networks. Later in the project we used Link, which is like a voice collaboration software. So really it was a learning curve for the office, but really within probably six months we had gone up that slope and got things moving. Yeah, but the initial phase, the first 3 to 4 months, was a lot of setup. There was a lot of traveling. There was a lot of dealing with the client, tying up what exactly he wanted, understanding the requirements. That phase is definitely a difficult stage in a project.
Yeah, the key there was that as well as a potential learning curve on 3D and BIM, there were so many other learning curves at the start of this project. But the same would be true for any international or overseas large multidisciplinary project like this.
Sorry, John, you mentioned aerial drones. Could you explain how the drones were used, or how you use them in your models?
Thanks. Well, during the construction phase, the scanners, the drones were used, I think, by the survey team. Correct me if I'm wrong, Dave. I think they were used by the survey team, and I think really they were used at the early stage almost experimentally, to be fair. I don't know, Dave, do you want to say any more about that?
It's probably where the industry is going, I suppose, getting site information back to design offices as quickly as possible. This was kind of done as a test case on the depot, where there was scan data and photographs taken, and they were draped over the scan data to pretty quickly get that information back to the design team.
They were successfully used in one of the civil engineering applications because mass balance for cut and fill in Norway is very important. Rock is a waste material for them. They have loads of it. So they don't want to, and it's expensive to excavate, it's expensive to dispose of. So they're very careful about understanding their mass balance in a three-dimensional way. In other words, where they're going to put it temporarily. We're cutting a whole pile of rock, we're excavating tunnels. There's another crowd out of the airport building and terminal, they had to knock a hill for that. So there's a whole pile of excess rock, and you're trying to use as much of it as you can within your process. You'll crush it, you may reuse it for concrete and the like, but understanding how and where you'll have it during the job is key. And they were using the drones to very carefully effectively survey the stockpiles effectively on a live timeline basis, because when you excavate, you have an assumed bulking factor. The bulking factor isn't always the same. depending on the way the blasting goes. So that was one aspect that they used the drone successfully for, to help manage that process.
There's actually a link at the end. There's a link to a tram cabin ride through. You'll get it on the slides. And actually, if you go to autoplay on YouTube, the one after that is a 6-minute drone view of the construction site as well. So.
So thank you for a very interesting presentation, both of you. There's two questions really, they're kind of related. One is, I think it was a design bid build project. So did you have to mandate the contractor to then take on board the BIM responsibility, I suppose, for integrating the project? And the second question is, if it was a design build, do you think you would have the opportunity to do the BIM modeling that you have?
Sorry, can I just clarify that? Your question.
Yeah, sorry.
Yeah, it wasn't a design build.
No, design bid build.
Or design bid. Yeah.
Sorry, so I was saying, how did you then make sure that the contractor took on board the BIM model concept? In other words, to extend your BIM modeling so that it became as constructed information.
He was told within the contract documents and discussed during the technical evaluation, because they have an interesting approach to running through procurement in Norway. He was told in the contract documents what we would be delivering, and he was expected or guided to take that on from there. If he chose to take the 3D model and go out with a shovel, not referring to the 3D model, that was his risk. It was to his benefit that he was getting this. So he was told the information he would get, the quality, the type, and he worked from there.
In most cases, the 3D model that we were developed during design was used all the way through, albeit information was cut and shared with the contractor. The drawings were shared. There was one or two cases, I think, in the depot building. For example, I think the sprinkler system, the contractor took over that. He brought in his specialist designer. He did his own modelling of the sprinkler system. But in 99%, our models went straight through. But you're right, it's not a typical contractual arrangement.
And in
necessarily.
the as-built aspect of that sprinkler system,
Yeah.
we then have to take his model back in at the end of the day so that there is a fully functioning model handed over to the client.
Sorry. So just trying to understand then, so they took your BIM designs, and so for the example you gave of the ducting there,
Yeah.
did they actually build the duct to your BIM design?
Yeah.
Right. And so what tolerances did you have on the BIM? So
That's a good question. We designed, we were told, and we stuck to a design of 1mm tolerance in the sense that our design was to be completely accurate in its own sense. Now then, clashing would have been maybe 100mm between objects. Clashing ranges depending on what you were talking about. The construction tolerance again was depending on what you were talking about, but wasn't very much at all, like, you know, maybe 50mm or something for very reasonably small tolerances. So now maybe it was a greenfield site, albeit you're going through tunnels and things, which possibly is easier to do setting out and so on. But if you're saying what tolerance, the tolerance on the design was the tolerance on the construction. There wasn't this huge grey area where things change and the construction becomes another world. It was, as far as I understand, this was the construction guys were coming back and saying it was being built. Dave? Sure.
It's about 1 centimetre is typically from the plant we're using, was the tolerances we're finding. So, like Jim was saying, the rock is a huge cost in construction, so the contractors were delighted to engage with the design in this way. There was no double handling to that. So by loading all of this information into the equipment, and then running that way is the fortune.
And I'd emphasize the fortune. I think that they tendered not fully appreciating the benefit of BIM to them. They were tendering based on, yeah, we'll get some benefit from that, and the more they went with it, the more they realised, yes, we can save money here. But that's the risk they took.
Yeah.
In terms of the civil structural design, were your codes used throughout? Were they accepted
Norway is not part of the EU, it's part of the EEA. They do, although they're not required to, generally follow European requirements. And that means that they do follow the Eurocodes with the Norwegian national annexes. So Eurocodes from a civil and building point of view were the primary design. However, they also have a document that they call Tech 10. It's effectively a technical building regulation, but it goes through a whole pile of requirements for buildings in terms of especially environmental efficiency, architecture, thermal conductivity, a whole pile of stuff like that, that as well as the codes, I mean, because we were familiar with the codes, you look at the national annexes, so it's a bit different from your own national annex, but understanding Tech 10, we really had to get up to speed fairly quickly with that. We did most of the time, but one or two things we had to backtrack on. There was an issue with Tech 10 because there was an imbalance between the daylighting requirements from an architectural point of view and the energy saving or energy efficiency from an energy point of view. And we weren't aware of this, and we went down a little bit down our design, and we found this incompatibility between our glazing, the amount of daylight we were required to let in, and again the energy efficiency. And when we sort of put it out to the wider community, to Rambo for example, everybody knows about this, you know, it's known in the industry, we can't comply with that. But this meant what we had to do is we had to go to the local commune and get a derogation, and the basis behind the derogation was that this working environment, you need to give a good working environment to the people. You have tram doors at the front that are going to be opening and closing like that. You won't achieve the balance you're trying to. So they accepted that a much more detailed technical argument to put it along those lines.
Okay.
No.
Thank you very much, Jim and John, for the presentation. It was interesting. At the start of your presentation, you mentioned the Safety Authority and the submission of the safety case. I'm just wondering, what sort of involvement did you have with the Safety Authority throughout the project, and how did you manage that interface?
The client had a single consultant within his organisation who interfaced with the Safety Authority. He was seconded in on a part-time basis because for the safety case, our safety case covered our element of the design. Within the overall safety case, there were two other elements that we had to coordinate into ours, the signalling and the telecoms, but as well as that, there are new trams coming in. And although we're designing around new trams, we're not responsible for the safety case aspect of the trams. So the client was stitching that together. We didn't interface directly with the NRA. This guy in the client's organisation did, but we provided the safety case into him. We gave him the safety case. He works with the NRA the whole time. He came back and said, no, they won't buy that. No, they won't buy that. So we didn't have a direct interface. That's how the interface worked.
Okay, I think we'll wrap up there. For anybody who has any more questions or would like to discuss the project, Mott MacDonald have an open bar for a couple of hours, so if you'd like a glass of wine or a bottle of beer, Jim and John will be there to discuss and
there might even be a few sandwiches.
So I don't see any questions from the web audience. I'm not sure if that facility was working, but there's email addresses at the end of the presentation, and everybody's very happy to answer questions going forward if you have them. Okay, so thank you very much.
Thank you.